Ho, 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 and welcome geometry students to 5.4 medians and altitudes. It's almost Christmas time. Hopefully you guys are on chapter 5 at this time, but if not, you can enjoy some Christmas cheer, no matter what time of year you watch this. All right, now, this is all about medians and altitudes. So we got to start off, what is a median? Well, a median is this thing. Okay, so let's go ahead and draw it in. A median is this. A median connects a vertex to the midpoint of a side of a triangle on the opposite side. Okay, so that is a median. Median meaning like the middle of a side, but the important thing is it connects the vertex. It's different than what we talked about before. Let me draw a triangle real quick. Usually Notability is good at recognizing triangles. Yes, it is. Okay. Usually when we're talking about perpendicular bisectors, one of the requirements is that it's the midpoint of a side, but perpendicular has nothing to do with a median. As you can tell, there's nothing perpendicular about this or this, okay? Perpendicular bisector doesn't necessarily go through the vertex, where a median does. This is a perp bisector. Okay, so it's a little bit different. Medians have a different kind of attributes. Now, this is a special case. So you're like, oh, Mr. West, I just saw a case where a median was a perpendicular bisector. Well, it's a perpendicular bisector when you're talking about an isosceles triangle. So don't pull a fast one on me. This is a special case where this is a perp bisector and a median at the same time. Okay, so it's a special case. It also happens in equilateral triangles, so don't try to throw that at me, okay? I understand, okay? So midpoint of a side connecting a vertex, median. Now, where the three medians meet. So again, you can draw medians from three different sides as long as you get to the midpoint. If you were to draw this as in construction, meaning do this yourself, you would need a ruler to measure the midpoint of each side. And then you would connect all of these lines together from the vertices, and you would get a special thing. What is that special thing? Sorry, I just want to erase it after doing it just because it looks nicer like that. Yeah, I like that better. Because I already did it here. Concurrency of Medians theorem. Now, they all meet up at a special place, and that special place is called the centroid. Isn't that a cool name? It's called the centroid. All right, now, the centroid is where all three medians meet up, and then it creates a special property. Now, the special property is that the lengths kind of, they hit each other in a special spot. So if we're looking at the purple line, okay, the purple line is composed of DC plus that CJ. This purple line is split into a specific ratio. So once you kind of look at it first, just so you can see if you can notice, is it halfway? Is this centroid halfway between D and J? No, it's not. Where is C in relation to D and J? It happens that it's 2/3. So DC is 2/3 of the whole length, which is DJ. So whatever you find for DJ, your full length there, you multiply that by 2/3 and you get DC, okay? Now, so that's 2/3. I want to write that. And what does that make CJ? I don't have this written here. Maybe I should add it. Email. Okay, let me add it, actually. I want to add it real quick. I know it's different colors, but you don't mind. So CJ is going to be equal to 1/3 of DJ, okay? By the same token, if one part is 2/3, the other part has got to be 1/3, okay? Now, FC, what's FC? We just have to look here, and it's going to be obvious. You're like, oh, how do you know which one's the 2/3 side? Well, one is clearly longer than the other, so one is clearly the 2/3 side, and that's FC. FC is going to be 2/3 of the whole length. I should use blue this time, sorry. 2/3 of the whole length, FH. So whatever you get for FH, you multiply it by 1/3, or sorry, 2/3, and you find FC. 1/3 to find CH. GC, okay, GC, this is what I was talking about. You just have to look here, and you can see that GC is clearly smaller than its counterpart CE. So GC in this case is the 1/3 section. Let's switch to green. So this is 1/3 of the whole length GE. And that is what's cool about medians. So let's get into some examples. Example 1, YA equals 15. So this whole length equals 15. What does YC equal? Well, we already know that YC is the bigger portion. Okay, so this is the 2/3 portion, and this is the 1/3 portion. So if we're looking for YC, we know that YC equals 2/3 of YA. We can substitute the value of YA, we know it, 2/3 times 15, and that equals YC. I like to put it over 1, okay, because then we can cancel. 15 divided by 3 gives us 5, so then we have 2 over 1 times 5 over 1. Guess what that equals? It equals 10. So we have 10 units, whatever that is. It should have been written as like centimeters or something, whatever. So now we have XC equals 8. We have this 8, this section is 8 right here. Let me change this to green. This section is 8 units, XC, and we want to find XB. All right, now we're going backwards. Okay, we want to find the big section now, given that we have the 2/3 section. Okay, so this is the smaller section. This is the 2/3 section. Well, not the smaller, but it's a smaller section. So now we're trying to go backwards. Let me go ahead and set up our equation. So we have, let's use purple. We have XC. We know this is the 2/3 portion of the whole thing, XB. This time we have XC equals 8. 8, and that is equal to 2/3 XB, and now we need to solve for XB. To get rid of that 2/3, we're going to multiply it by the reciprocal to both sides. I like to put it over 1. We can recognize that we can cancel the 8 with the 2, and that's 4. So then we have 4 times 3, and that's 12 equals XB. 12 units. And that's all we got. So that's all we got for this part 1. We're probably going to have a part 2 as well. But stay tuned for that. We're going to talk about a new topic. Hope you enjoyed this section about medians. Can't wait to see you come back.